Hello. In the last video, I skipped over units real quickly because I said I was going to record a video only on units. So this is what we're going to be doing now. We talk about how without units, a number is meaningless or confusing. Unfortunately, the United States uses, everybody calls it the British system, it's actually the United States customary system. Doesn't matter. It's derived from the British imperial system, and it's both of them, the British and the United States systems, have put in their cumbersome. I think a better definition would be insane. I'm probably biased because I grew up using the metric system all my life, but I just don't understand why any country still sticks to inches, pounds, Fahrenheit, and all of that. To begin with, there's no memory involved. I mean, you have to memorize how many yards in a mile, how many ounces in a pint. So many people don't know the numbers. I mean, not too long ago, we was doing the lab, a chemistry lab, and we was comparing the metric system versus the US system. And I bought a measuring cup, a kitchen measuring cup, and I was telling the students, measure 1 quart with this cup. And then you're going to put it into a graduate cylinder and see how many milliliters that is. And they were supposed to do some calculation with that. The problem is the measuring cup only had was ounces. So the students come and say, how many ounces in a quart? You don't know that? I mean, if I don't know, I feel like I'm entitled because I never use ounces. But you was born with this system. You don't know how many ounces in a quart? I have to get a permanent marker and mark a line. Okay, this is 1 quart. Now you can do the experiment. But there's so many numbers that you have to memorize. Really, I shouldn't be surprised that people didn't know. The calculations are more difficult. I mean, if you try to calculate, I just made that up last night, a third of your measurement that is 5 3/16 of an inch. Oh, well, yeah, I know you can do it. I've seen my children do it. Convert everything to 16ths of an inch, divide by 3, and then change it back to inches and 16ths of an inch. That's so complicated. And the more steps you do, the more likely you are to make a mistake. And then some people use units that they don't even exist. And I guess as an example, the crown. It happened to me. Before coming to the States, one summer I went to England, kind of practice. I had taken English throughout high school, but there's a big difference when you're trying to talk to people. So I went to England for a month. It was a weekend. I didn't have no classes. And I was walking around, and there's that nice little store, and there was a beautiful dress in the window. Oh boy, I like it. And it had the price in crowns. I wonder if that's a good price or a bad price. And I look in my wallet, and I say, I don't have crowns in here. And it's okay, because I have my pocket dictionary, and I had made a chart how to compare British currency to Spanish. So I could compare numbers. I don't have crown in there. I look it up in the dictionary, and of course it defined crown as what the king or queen puts on her head. I walk in the store, and there was a fellow, the typical British fellow, skinny, serious, cold like ice. And I asked him, excuse me, sir, what is a crown? And he looked at me and said, I saw you looking at the dress. Yes, sir. Well, if you don't know what a crown is, you don't need the dress. What? You don't need the dress. I left the store. I don't know if I was mad with the fellow, because I thought he was very rude, upset, because if it had been a good price, I'd have bought the dress. I was so confused. Monday, when I got to class, and the teacher asked, did you do anything during the weekend? Have any questions? I did ask him, what is a crown? And he started laughing. You try to buy something? Yeah. And he explained to me a crown is monetary unit that doesn't really exist. He said maybe there was a time he couldn't swear, it hadn't existed in the past, but he said it doesn't exist today, that's why you didn't have any crowns in your wallet. It is £1 and 1 shilling. So what you're telling me is that the stores are putting prices in units that don't exist? Yes. All I could do was shake my head and say, why don't you people use the metric system? The fact is, a metric system, it doesn't eliminate memory. You're going to see that you have to memorize units and prefixes, but not as many numbers as you're going to have to memorize with the British system. The calculations are very easy, because all you're doing is multiplying or dividing times 10 or multiples of 10. And all of the units exist. So, yes, I understand I'm biased, but a metric system is so much easier. Let me put it this way. In Spain, students learn the metric system in the 2nd grade. So it cannot be that difficult, okay? I know every time we have to learn something new, we get all nervous and upset, but it's easy. A 2nd grader can do it. So the metric system uses base units. The base units tell you which property you're measuring. And then you have prefixes to indicate numbers that are much bigger or much smaller than the base unit. And we did say in the previous video that in chemistry, we are using the International System of Units, the SI system, and we said the only difference was the SI system uses kilograms, using their mass, uses the kilogram, while the metric system uses grams. Everything else is identical. So this is what you're measuring, this is the unit, the symbol. Do I need to memorize this? Some of them. There's some that you're not going to be using at this time. You do need to be able to measure length, and we use the meter. So yes, you want to know this unit. Mass, kilograms, time in seconds, temperature, we're going to see that we can actually use degrees Celsius too. You don't need to worry about electrical current yet. In the 2nd semester, when we do electrochemistry, we'll get back to here. Amount of substance in moles, yes. And you're not going to use luminous intensity, so you don't need to memorize this. The two that are crossed out, they are real units. You just don't need to know them by now. Okay? As far as the prefixes, I have 2 tables in here. The first table tells you when you have units that are smaller than the base unit. The 2nd table when they're bigger. And maybe there is too many to memorize to begin with. It tells you the prefix, the symbol again, and the factor. So if I say that I have 1 millimeter, I look at milli and say, oh, that's 10 to the minus 3. What is the base unit? Meter. So you do need to memorize, but at this point, for college chemistry 1, I'll memorize micro, milli, centi, deci, kilo. If you ever need any of the other ones, you can look it up. But you don't want to be looking back all the time. So at least those ones, you need to memorize them right now. Once again, practice, practice, practice. Get a worksheet where you're making conversions between units so you get comfortable using the metric system. I don't want to spend a lot of time defining the units like the meter. Well, when I was in elementary school, it was defined as 1/10,000,000th of the distance from the North Pole to the equator, and not anywhere. It had to be the meridian that passes through Paris, because the Earth is not perfectly round. Then we define it now as the distance the light travels. As far as you're concerned, a meter is very close to a yard. It's just good sometimes to have an idea. Like one of my favorite questions is ask, what unit do you use? You try to use the unit that's the closest. So you need to have an idea what the unit represents. Okay, but it's very, very close to a yard, just a little bit more. For mass, remember the SI system uses the kilogram, the metric system uses the gram, and that's all you want, like a metric system there, because the gram is a base unit. Kilo, we said it was a prefix. So the SI system is using a prefix as if it was a base unit, and I don't like that. The reason they use that is because they said that's the mass of a liter of water. Okay? So since the liter was the unit for volume, I just think they make life more complicated like that. But kilogram is a bit over 2 pounds. Talk about culture shock. When I came from Spain and I weighed myself for the first time, my weight more than double. Takes you a while all of a sudden to figure out the new numbers. I spent the first 6 months walking around with a calculator, converting everything back to the metric system until I figured enough is enough. I need to get used to the American system. The SI unit for temperature is Kelvin. Please do not call it degree Kelvin. Okay? It's not degree, it's just Kelvin. I know it sounds funny. You do not use the degree symbol. It's just Kelvin. Now, the SI system allows you also to use degrees Celsius. Okay? Both degrees, the Celsius and the Kelvin, have the same magnitude. The difference is where to put the zero. The zero is going to be the temperature at which water freezes, and it's 273.15 Kelvin, or 0 degrees Celsius, and at what temperature water boils, 373.15 Kelvin, or 100 degrees Celsius. You can tell that there's 100 degrees, whether Celsius or Kelvin, so 100 Kelvin and 100 degrees Celsius cover the same temperature interval. Most of the time, we are going to be using degrees Celsius. And the reason is we don't have Kelvin thermometers. Okay? Any thermometer you buy in the lab is going to be a Celsius thermometer. Okay? We don't have 0 degrees, 0 Kelvin would be the lowest possible temperature. It has not been reached yet. There's no thermometers that measure that low. Okay? But please, please, please do not use Fahrenheit. These are conversions, how you convert from Fahrenheit to Celsius, because it happens all the time, you have to do it. This one, I usually give it to the students. Once again, the instructor may not do that, I don't know, but I was telling you need to know how to change Kelvin to degrees Celsius. Okay? But this is usually given because you can look it up anytime. It's, I call it scientific trivia. Okay? But there's a tremendous difference between Fahrenheit and Celsius. Like I said, you cannot do it easily. Talk about, again, culture shock. Well, actually, I came to this country in August, so that was November. I should have known better. But I got up in the morning, I had the radio on, I was living in Washington, D.C., I was listening to Super Hawk Report, the report about the Redskins, and I wasn't thinking, and then they said the temperature is 30 degrees. And in my mind, 30 degrees is hot. I didn't stop to think this is not Celsius. I didn't stop to think it's November. I didn't stop to think how it was the day before. I just said, oh, 30 degrees, nice. And I put on a pair of shorts, a t-shirt, flip-flops, stepped out. Oh, my goodness, it's cold. I'll never forget that. That's when I decided I need to quit thinking in the metric system and start using the American system. I cannot spend the rest of my life with the calculator converting, because when I don't do it, that's the kind of stupid things I do. As far as time, the SI unit is second. Obviously, you can use milliseconds, nanoseconds, but many times you're going to see times expressed in hours, days, years, but the appropriate unit is the second, and many times you're going to have to convert your time into seconds. We saw that there were 7 base units, but sometimes you measure other things that we call derived units, meaning that you combine some of the base units. For instance, volume, the amount of space. If you had, for instance, a cube, how do you calculate the volume of a cube? You say, well, that's the height times the width times the length. So if the base unit for distance, for length, was meter, obviously the base unit for, or the unit, sorry, the unit for volume is going to be the cubic meter. Now the problem is cubic meter is real big, okay? So most commonly we are going to be using liters and milliliters. Remember, milli is 1,000. So this is 1,000 of a liter. This particular equality, you need to know it. 1 cubic centimeter equals 1 milliliter, and remember that can be expressed also as cc. Why do we do that? Because lots of people use cubic centimeters, especially when you get into the limit, that gray area between chemistry and physics. When you're dealing with pure liquids, you use milliliters. When you have to measure it, you're more likely to use cubic centimeters. You're going to be seeing both units all the time, and you need to know that they're the same. Okay? We just said before, how do you measure the volume of a cube? There's many things that there's a formula to measure the volume, but what if you have a shapeless object? How do you measure the volume? You're going to see this very common in chemistry. It's called word displacement. So you fill a graduate cylinder, you read the initial volume. Now very carefully not to splash, you put that object in there, the volume goes up. The difference, the final volume minus the initial volume, that's the volume of the object. Obviously this works if the solid cannot react with water. If it reacts, you cannot do that. Try to put a piece of sodium and you have an explosion. If it cannot float, because if it floats, only part of the object gets in the water, so it won't work. And you don't want it to dissolve either. Because if it dissolves, it will increase the volume a little bit, but it's not going to be the volume of the initial, like if you put a lump of sugar, the volume barely changes at all. You may not be able to tell the difference. Okay? But as long as these conditions are fulfilled, this is how you measure volume of an object by word displacement. Another derived unit that you're going to use a lot is density. It's the ratio of the mass to the volume. So what is the unit of mass? Kilogram. Come to the SI system with a volume with a cubic meter. Now this is a very odd unit, okay? And you're never going to see it in chemistry. What unit we use is going to depend on the state of the matter, because solids and liquids have a higher density than gases. So with solids and liquids, we use grams per cubic centimeter or grams per milliliter, the same thing, remember? With gases, we're going to use grams per liter. Those are the commonly used units. Once again, practice, practice, practice. Do you want to work with me one-on-one? Do you want to have access to my worksheets? Do you want help preparing for an exam? Go to the video description, find a link to my Wizard profile, and make an appointment.